Alright, so we've done a bunch of square roots of positive numbers. What if we're trying to take the square root of a negative number? If I want to take the square root of negative 25, it's impossible to find a real number because if I have two negatives, negative 5 times negative 5 would multiply to a positive 25, and negative 5 times positive 5 would multiply to a negative 25, but these aren't the same number. There needs to be a single number that's going to multiply to a negative 25, where it's the exact same number. Okay, so it's not possible to do that with a single number, either negative or positive. So to make sense of the square root of a negative number, we introduce an imaginary number. The square root of negative 1 is understood to be an imaginary unit, and we just call it I. The square root of negative 25 is going to be the square root of 25 times the square root of negative 1, and therefore we're going to call this 5I, the square root of negative 1 being I. Let's look at a few examples here. The square root of 49. You know the square root of 49 is 7. Since it's the square root of negative 49, this is going to be 7I. This is negative the square root of negative 81. The square root of negative 81 is going to be 9I. So this is negative 9I. Right? In example C, I have negative the square root of negative 3 over the square root of 20. Notice there's only a single negative here. You can either choose to put it on the top or the bottom, doesn't matter, but make sure there's only one. And on the top right here, we're going to take that negative in the square root and write it as an I outside of the square root times the square root of 3. And for the square root of 20, since it's in the denominator, I need to figure out what I can multiply this by to make it a perfect square. So I know that 20 goes into 100, which is a perfect square. So if I multiply both top and bottom by the square root of 5, I'm going to be able to get this as negative I times the square root of 15 over the square root of 100, or for a final answer, negative I times the square root of 15 over 10. Okay, let's look at part D. The fraction 2/54 reduces, and since neither of those numbers is a perfect square, we're going to go ahead and reduce this. This is the square root of negative 1 over 27. So we can separate this into the square root of negative 1 over the square root of 27, or I over the square root of 27. Now, since the square root of 27 is not a perfect square, I'm going to need to multiply top and bottom of that by a number that's going to make it a perfect square. 27 goes into 81, which is a perfect square, so we're going to multiply top and bottom by 3. So this is going to give us I square root of 3 over the square root of 81, and a final answer of I square root of 3 over 9. It's been rationalized. Okay. Imaginary numbers are the numbers of the form we were looking at before, where it's a number times I. In part D right here, the number B, it happens to be the square root of 3 over 9 times I, and letter B up here, it was negative 9 times I. Complex numbers are numbers where you have an imaginary part, something multiplied by I, and a real part, something added to that sum. So some examples of complex numbers might be 3 plus 2I, or 7 minus I times the square root of 2 over 5. These are just examples of complex numbers. They have a real component, a part that is not imaginary, added to a part that is imaginary. I've got some complex numbers I want to simplify here. Now notice that these complex numbers actually represent two numbers. This first number here is 3 plus and 3 minus the square root of 9. But I can simplify them together. So in the first one, this is 3 plus or minus the square root of 9 is 3 over 21. Now, because you can add 3 and subtract 3, we're going to split this into its two separate numbers. One of them is 3 plus 3 over 21, and the other one is 3 minus 3 over 21. Okay? Keep simplifying. You know that 3 plus 3 over 21 is 6 over 21. And 6 over 21 reduces to, divided both by 3, 2/7. The other number, 3 minus 3, is 0 over 21, which is 0. All right, in part B, this is a similar problem. We have 3 plus or minus the square root of negative 9. Since the 9 is negative, this is 3 plus or minus 3i over 24. Now you cannot add 3 and 3i since one is real and one is imaginary. We can reduce these by factoring out a 3. So this is 3 times 1 plus or minus I over 24. And you can divide both 3 and 24 by 3. It'll give you 1/8. So this will simplify to 1 plus or minus I over 8. Now again, if you're going to be entering this answer into my math lab, it's going to want you to type those answers as 2 separate numbers. So the first number is 1 plus I over 8, and the second number is 1 minus I over 8. Part C, negative 4 plus or minus the square root of 40 over 2. Let's first go about breaking down that square root of 40. So this is negative 4 plus or minus the square root of 4 times the square root of 10 over 2. So that's negative 4 plus or minus 2 square root of 10 over 2, since the square root of 4 is 2. The numbers on the top can be factored. You can take a 2 out. So that's 2 times negative 4 plus or minus the square root of 10 over 2. And if you divide them both by 2, your denominator becomes 1, so you really just have negative 4 plus or minus the square root of 10. In part D, we have negative 4 plus or minus the square root of negative 160. I can right away say that that negative is going to come out as an I, so I can pull my I out front. Now 160 can be represented as the square root of 16 times the square root of 10, and 16 is a perfect square, divided by 2. So I've got negative 4 plus or minus 4i square root of 10. When I have an I usually write it to the right of any whole number and to the left of any square root. So that would be the proper place to put it. Divided by 2. Now, you can factor 2 out of the top, so you're going to have 2 times negative 2 plus or minus 2i square root of 10 over 2. So your final answer is going to be negative 2 plus or minus 2i square root of 10. In part E, we have negative 8 plus or minus the square root of 1,200. And 1,200 can be written as the square root of 100 times the square root of 12 over 40. Okay, so that gives us negative 8 plus or minus 10 times the square root of 12. But notice how when I simplified the square root, I didn't actually pull out the biggest perfect square. The square root of 12 can be broken down further into the square root of 4 times the square root of 3. If you don't happen to find the biggest perfect square, that's fine. Just break it down again until you have broken down all perfect squares. So now I have negative 8 plus or minus 10 times 2 square root of 3 over 40. So that's negative 8 plus or minus 10 times 2 is 20 square root of 3 over 40. You can divide both 8 and 20 by 4, so let's factor that 4 out. That'll give me negative 2 plus or minus 5 square root of 3 over 40. And dividing that 4 into both 4 and 40 will give you the negative 2 plus or minus 5 square root of 3 over 10. That's as simplified as that one gets. Let's look at part F. I've got negative 4 plus or minus. I can start with I since I know I've got a negative in the square root. Let's try to break down 128. I know that 16 goes into 128 8 times. So I can write this as negative 4 plus or minus 4i square root of 8. But I know I haven't actually managed to find the biggest perfect square, since square root of 8 can be written as square root of 4 times square root of 2. So let's try again on that one. That'll be negative 4 plus or minus 4i I times 2 square root of 2 over 20. And we know that 4 times 2 is 8, so that's negative 4 plus or minus 8I square root of 2 over 20. You can factor a 4 out, so you're going to have 4 times negative 1 plus or minus 2I square root of 2 over 20. And if you divide that 4 at the top and bottom, you're going to be left with negative 1 plus or minus 2I square root of 2 over 5. Okay, let's check out the next page. Example 8. There's a few equations to solve here using the square root method. In the first one, x squared is equal to negative 25. So when you take the square root of both sides, you're going to get x equals plus and minus the square root of negative 25. So my answer is going to be positive and negative 5I, since there's a negative inside the square root. Okay, in part B, let's take the square root of both sides. It's going to give us t plus 5 equals plus and minus the square root of negative 64. So I have t plus 5 equals plus and minus, the square root of 64 is 8. There's a negative in there, so it's going to be 8I. I need to subtract 5 from both sides. 8I and 5 are not like terms. One's real and one's imaginary. So we're going to write this as t equals negative 5 plus and minus 8I. This is a complex number, so the real part, the negative 5, should be written before the imaginary part. Again, this does represent two different solutions. This represents t equals negative 5 plus 8I and negative 5 minus 8I. So whether you write it with the plus and minus symbol on paper, that's fine, or if you want to write it as two separate answers. But when you go to type your answers into MyMathLab, they better be two separate answers. Okay, part C. 2a plus 4 squared equals negative 4. Take the square root of both sides. It's going to give you 2a plus 4 equals plus or minus the square root of negative 4. So 2a plus 4 equals plus or minus the square root of 4 is 2. Negative is going to turn into I. Now subtract your 4 from both sides. 2a equals, so not like terms, the negative 4 is going to just go out in front of the plus or minus 2I. Divide everything by 2. So I have a equals negative 4 plus or minus 2I divided by 2. This can be simplified because the top can be factored. You can divide a 2 out. So a equals 2 times negative 2 plus or minus I over 2. And then your 2's divide to 1's. So you have a equals negative 2 plus or minus I. And the very last one here, part D. My perfect square is by itself, so we're going to take the square root of both sides. X minus 3 equals plus or minus the square root of negative 32. So I have x minus 3 equals plus or minus. I can go ahead and write I, since I have a negative in my square root. And the square root of 32 can be broken into the square root of 16 times the square root of 2. So x minus 3 equals plus or minus. The square root of 16 is 4 times my I times my square root of 2. Usually if I have a number multiplied by I, it goes in front of the I. And then when I add my 3 to both sides, I will have x equals, these are not like terms, 4I square root of 2 is not like 3. So the 3 is just going to be added to the front. That's the real component. So 3 plus or minus 4I square root of 2. A real number comes before an imaginary number, and in the imaginary number, the I is after any part that's not in a square root, but before any part that is in a square root. So those are your two answers. Complex solutions.